Moin Moin from Hamburg. My name is Onno Martens. I'm with R&D here at Trinamic, and today I would like to show you our brand new FOC servo controller IC, the TMC4671. In this demo we have two servo motors controlled by two individual TMC4671 and one AT-tiny microcontroller performing initialization and synchronization of the movement. It was the smallest micro we can find to run our short application code. On top of this, the TMC4671 provides some really nice features which are hard to implement in software. For example, our parallel processing of all tasks, our high controller update rates of up to 100 kHz to drive low inductance motors, and some filtering and interpolation features like the digital Hall signal interpolation. But let's have a look into the TMC4671 and the FOC technology inside. The TMC4671 comprises all real-time functions for a full servo control structure, including a PWM engine, 8 delta sigma ADCs with configurable digital filters, our FOC servo control engine, a decoder engine, and a register bank with communication interfaces as SPI, UART, and RTMI. To most of our customers, FOC and servo control is a mystery because it is simply out of their focus. They are building 3D printers, lab automation equipment, pick-and-place machines, or any other device containing a single or multiple motors. To understand FOC, which is field-oriented control, we have to know that in every motor, torque or force is generated by a combination of two things. First, the current, and second, the magnetic flux. In a common DC motor, like this one here, flux and torque are generated by applying current to the motor coil. From controller's perspective, the FOC algorithm is basically turning a BLDC or stepper motor into a common DC motor, which is easy to control. Therefore, it uses mathematical transformations called Clark and Park transformation and two simple PI controllers. One controller is responsible for torque control, the other one takes care of the additional flux in the machine and is thereby called flux controller. Controller outputs are transformed by inverse Park and Clark transformation to phase voltages. These phase voltages are modulated via PWM and provided to the switching power stage. So to make the FOC work, we need two kinds of feedback from the motor. First, we need some current sensors to measure the phase currents, and second, we need a position feedback system. The TMC4671 processes incremental encoder signals, digital and analog Hall signals, and sine-cosine encoders. All feedback systems are processed in parallel, so users can apply multiple feedback systems and use one for commutation and another one for positioning. Velocity and position controller complete the fully cascaded servo control structure. As the update rates of the controllers are quite high with a sampling frequency up to 100 kHz, the response to load is quite fast, allowing for high dynamics. And as the applied current is always aligned to the magnetic axis of the motor, maximum efficiency is achieved. You see, there is a lot of control engineering inside this chip, but you don't have to be a control systems engineer to set this IC up in your application. To set up this demo, we needed this piece of code, which counts only 150 lines. For initial startup of the IC, we provide powerful tools. including our TMCL IDE with a configuration wizard, a register browser, and auto-tuning tools. Also, our enhanced API makes software development much easier and faster, and the USB to RTMI adapter here allows real-time measurement access to registers while using the TMC4671, which is crucial for easy and fast commissioning. Thanks for watching, and as we say in Hamburg, tschüss und auf Wiedersehen.